Usually when choosing a significance level, we're going to use the default industry standard of 0.05, and almost every problem this quarter will end up using 0.05. However, it is often helpful to adjust that significance level based on the application. So for example, sometimes you may go with 0.1 or sometimes you may go with 0.01. Those are also commonly used levels of significance. So how do you choose? Well, it goes to the type 1, type 2 errors. If making a type 1 error is dangerous or especially costly, we should choose a small significance level, like 0.01. In this case, we would need to demand very strong evidence favoring the alternative before we end up rejecting the null hypothesis. So this is often a situation where medical studies where people's lives are at risk. You want to make sure that you get the results before you start rejecting the null hypothesis. On the other hand, if a type 2 error is relatively more dangerous or much more costly than type 1, then we should choose a higher significance level like 0.1. This would make it easier to reject the null hypothesis and harder to commit a type 2 error. In this case, we'd want to be cautious about failing to reject the null hypothesis when the null hypothesis is actually false. Okay. For example, a part inside of a machine is very expensive to replace. However, the machine usually functions properly even if this part is broken. So the part is replaced only if we're extremely certain it is broken based on a series of measurements. So let's identify the hypotheses, the type 1, type 2 errors, and suggest an appropriate significance level. Well, in this case, either the part is not broken or the part is broken. In terms of which one is which, we want to try to prove the part is broken, so that's going to be the alternative hypothesis. That would make the null hypothesis the part is not broken. Now in this case, a type 1 error would be the null hypothesis is true, but we reject it. So the type 1 error would occur if the part is not broken, but we think it is, and replace it at great expense. A type 2 error, on the other hand, is where the alternative is true, but we fail to reject. So a type 1 error in this case would be the part really is broken, but we don't think so, continue to leave it alone. And in this case, the part, the machine still seems to function, no real great cost here. So financially, a type 1 error is a lot worse, so reducing a significance level to 0.01 would be appropriate. Another example, an airplane mechanic inspects a plane to determine if the plane is safe to fly. So let's identify type 1, type 2 errors and suggest an appropriate significance level. So what we're trying to do is we need to prove that the plane is not safe, so that's going to be the alternative. The null hypothesis is that the plane is safe to fly. So a type 1 error would be the plane is safe, but we think it isn't. So a type 1 error would be made if the plane really is safe, but the mechanic grounds the plane anyway. A type 2 error would be made if the plane is really not safe, and the mechanic thinks it's safe to fly. So from a safety standpoint, a type 1 error is going to be worse. So increasing significance level to 0.1 would be appropriate. A police officer pulls over an individual that was driving recklessly. The police officer is trying to determine whether the individual should be arrested for driving under the influence of alcohol. So in this case, they're trying to prove the individual is driving under the influence. The null hypothesis is that the person is not driving under the influence. So a type 1 situation, again, is where the null hypothesis is true, but we reject it. So the individual is not under the influence, but is arrested anyway by the police officer. A type 2 error is where the alternative is true, but we fail to reject it. So a type 2 error would be made if the individual is under the influence, but the police officer lets them go. Now, in terms of which one is more significant, you can decide for yourself. For myself, neither error would be good, but from a safety standpoint, a type 2 error is worse. Keeping the significance level at 0.05 or increasing it to 0.1 would be appropriate. Alright, finally. The head of the cartel wants to know if there's a mole among his crew. So in this case, the alternative, what you're trying to prove is there is a mole. So the null hypothesis is that there is no mole. The type 1 error in this situation would be that the null hypothesis is true, but we reject it. So type 1 error would be that there is no mole, but the head thinks there is. So paranoia all around. A type 2 error in this case, where the alternative is true but we fail to reject, that would be that there really is a mole, but they go undetected. Which error is worse? I guess it depends on your perspective in this case. From a general standpoint, keeping the significance level at 0.05 may be appropriate.